Be careful on that first slide, guys, or the table. It's asking you for the a squared, the b squared, the c squared, right? You're not trying to figure out what is a. You're trying to figure out what is the a squared. What is the b squared? So as you're looking at the worksheet, too, that goes with this, and then I'm going to give you a few minutes to work, our goal for today, and by the way, so I got a Desmos, trial. So we use Desmos a lot with what CPM has connected. Desmos has its whole own curriculum. I could teach Desmos all year long, except it would cost a bunch of money. I got a 30-day free trial, and I love Desmos, so we're going to use it. So our goal for today is to be like Pythagoras, or better than Pythagoras. And by the end of class, you'll know how you could be even better than Pythagoras. So you can use this as you go. You've got the little table of stuff on the, I think. Did I give you the table on the worksheet or no? No, maybe I didn't. Well, because the table's in the activity. Be like Pythagoras or better. Yeah, likely. Tron, you're going to want to go back and double check slide 1. So, what's the post-it on my pencil thing say? Now, you have to come admit to me where your pencil has gone, the fact that it's at the end of the school day.
My sister.
Have you not had a pencil all day?
My sister stole every single pencil.
How have you survived the day?
I had one most of the day.
Then where did it go?
I had to return it.
Guys, we seriously are running low on pencils. You gotta try to keep track of your pencils. Put it in your pocket of your pants. Put it in a pocket of your backpack. We are seriously running low. All right, I'm trying to give you guys a couple minutes to get a head start before I talk about things.
Oh, there is a calculator. Never mind.
So if we check out the formula on the worksheet, or if we check out the poster up in the front of my room, or if we use what we just heard in the video, you don't need to know what C is to know what C squared is. You do not need to know C to be able to figure out C squared.
I'm not very thinking right now.
Xavier, why'd you skip slide 1, bro? Go back. Go. For my percussion people, the video or the music that we're listening to right now is just like an NPR concert. But I find it very interesting that instead of bringing like a whole marimba or whatever, they just brought the keys they wanted.
I just realized how...
Yeah, see, they just brought the keys they needed. Just those keys.
That's what Mrs. Ballright used to do.
Look, you don't always need the whole thing.
She's like, helicopter, take the bars off the room. Yeah, that was so weird.
Hey, man.
She'd be so nice, and then she's like, so if you break it, I'm gonna steal your family or something. She's like, these cost like millions of dollars.
Alright, so pushing aside the stories from the past, when you get to slide 2, which it looks like most of us are on, you're gonna need this paper. And if we know that a squared plus b squared equals c squared, we should be able to process through any of this. So I'm gonna write again up here. And yeah, for a moment, I'm going to sync everyone to me. It's like a teleportation, right? Or like a black hole sort of thing. So, let's use some random cards. Gwen, if I look at triangle D, and I want to figure out what A squared is, because Pythagorean uses a lot of stuff squared. What would A squared be there? So let's go ahead and draw that on our paper. A squared would be 4. Adrian, what about B squared? Yeah, because B is 4. So then, even though we don't know the length of C, because it's diagonal and we can't really count it, what should C squared be? Yeah, because it's the sum of your A squared and your B squared. So even though we don't really know what C is right now, yeah, and that drawing's only so good, we know it would have to be 20 because the Pythagoreans proved this. Lots of people proved it. Even a previous president proved it. Anyone notice anything about triangle E that makes it kind of nicer? Owen? Ooh. It's kind of symmetric, right? Like it's evenly... So wait, what else could we say? I agree with what you said. What else could we say, Henry? Ooh, these are going to be equal to each other. Take a moment. I'm going to try to let you head start. That's that's the hardest thing. So wait, what is C squared here? 36. So wait, Henry said A squared and B squared are going to have to be the same. And they have to add up to 36. So Henry, can you say again a bit slower what you're going to do with the 36? Oh, and actually, this is really nice that it's not 3, but it's like diagonally through 3. So I could also just diagonally through 3, diagonally through 3, and diagonally through 3. So this is B squared would be 18. Joe said 17. It's 18. Come on.
Well, I didn't get the wrong number.
He was checking to see if we were paying attention. You know, just Joe making sure we're awake. Now, wait a minute. F. And guys, if you've moved on, I'm real worried because, well, quite frankly, the person who's moved on, you don't have the right answer. So you know if that's you. If you've moved on, you do not have the right answer. Come back with us. I had us synced and I let you go, but maybe I shouldn't have. Come back to slide 2. Is this countable how it sits? No. Does anyone have an idea? So I want to channel back to my favorite professor that I've talked about over and over again. Who was my favorite prof?
Prof?
Mr. Dr. Smith, right? Which of course Owen remembers because his dad's name and his name. But Dr. Smith would always say, if we don't know what to do, do anything. Okay, so that's kind of vague. Anyone have an anything suggestion, Lucy?
If you turned it like A, there's like 2 little blocks beneath it. If you turn it so it lines up with those.
But it's not gonna. I agree. If we could, it's gonna be like right here or something, because we know that's longer than 2. Right? We know that's longer than 2. All right, I'm yanking everyone back with me because the people that have moved on do not have right answers. Adrian?
Double it and make that square.
I mean, we could make a rectangle. Now, guys, what if I asked you to try to figure out B, and there wasn't any other part of the triangle there? Could I make B the hypotenuse of a triangle? So let's review vocab. Right triangles have 2 legs, just like you do, and the third side across from the 90, which is actually under, if you want to know why hypo gets used for this, the side that's under the 90-degree angle is always referred to as the hypotenuse, which in our Pythagorean theorem is that C piece, right? It's that C. So, hold on, stick with me. B. What if I draw this and that? Now B is actually the hypotenuse of a new triangle I just made. Because I didn't know how to deal with this triangle, but channeling Dr. Smith, he'd say just do anything. And if you don't know what to do, just draw a line. Like literally, a lot of times just drawing a line can help us. So what is this? Well, that's 4. So what's 4 squared? 16. So wait. B squared would be how much? This B squared would be 20. Right? Because that 16, that 4, the new hypotenuse that I made. Can I do that with this C side? So hold on. I'm not going to keep talking because I want you guys to take a couple minutes and do it, but I'm going to draw. On your paper, you should be making new right triangles. And I'm actually going to fill this one in with highlighter. So we're forming new right triangles that line up on the countable lines. So this right triangle, it's a famous right triangle. Ah, can I have a signature? An autograph? Get it? It's famous. Now, if you are confident in what you have done, I did unsync you guys, so you can try to move on if you want, if you are confident with your answers. Hey, why did I say this green triangle's famous? It's the 3, 4, and we just saw from that video, every right triangle with legs of 3, 4 have to have a hypotenuse. I want to make sure more than just Henry heard it. If we've got 3 and 4, what's the hypotenuse? 5. So this C here, this has to be 5. Joe, go back and check those answers. Kylie, go back and check those answers. Adrian, go back and check those answers. Yeah. Slide 2, you had something incorrect. Yep. Here, let's review this together then. All right, so all of us have been looking at this. For triangle D, guys, unless you're super confident in your answer, I would think you'd come back and look at this with us. For triangle D, we said the A squared, and that one's not too bad because it's countable. That A squared, and sorry if you're watching the video, you're not going to be able to see what I'm writing. The A squared was 4, the B squared was 16, and we know C squared is always just the sum of them. Then we said, for triangle E, the C squared we knew was 36. Henry told us split that in half for the A squared, B squared. Guys, I think some of you are actually trying to type in what A is or what B. We're doing the squared today. right? We're doing the squared. So for f, that's the toughest part that we just talked about. We found out after drawing that new, I'm going to clear this so I can scroll down. We found out after we drew those new triangles over here that b squared had to be what? 20. A squared. Ooh, careful. We made, this is where I think y'all are falling into the trap. Crap, I left that locked. It's not 4. Guys, look at what you did. We did this. We made that, but what is 1 squared? 1! Adrian, what's 1 squared tell us to do? 1 times 1. So a squared has to be the sum of these. What's 4 plus 1? 5. A squared has to be 5 there.
Wait, Mr. Hudson, if you already had it like 25 and you got it like wrong, you said it was like wrong. How is it wrong?
No, this is 25. The c squared.
Yeah. Yeah, but like before when you were calling out like who was wrong.
Then you had something else incorrect in your table. I'll go back and check I gotta drag this over, but I can go and check the answers again. For people that have moved on, it looks like Henry, Xavier, you should go check your answers that you have in there. It looks like you typed something wrong. You fell in the trap of accidentally giving what A is instead of like A squared, or C is instead of C squared. So Xavier, you're C squared on triangle F. Go back and check C squared on triangle F. Guys, you have the worksheet. Don't just blindly try to remember what I said. Look at your worksheet. Gwen and Henry, we both need to go back to that slide. No, you didn't. Gwen, on triangle F, C squared was 25. No, you didn't. I'm looking at your answer. Zara, where'd you disappear to? But we've moved way farther than that. And you have like all the work that we just did there. Like, come on. Let's not play games because you had left the Desmos. You weren't even in Desmos anymore. At least I couldn't see you. So my suspicion is you were tab jumping and doing something else. Yeah, I released you again, but I want us all to look at this together for a moment. Grab a seat. So, does this work for every triangle? You need to play with this and see, does it work for every triangle where a squared and b squared would equal c squared? Right now my a squared is bigger than my c squared. if you did not drag anything around to play with it, this probably will not make sense. Now, on Joe's question of would that work, I have a question for you to ponder.
That definitely does not work.
Would this... So this works for what type of triangles? Right. Does it work for other triangles? No, because those triangles are wrong. Right. Okay, no, so right triangles, this works. A squared, B squared, C squared. It doesn't work with other triangles. But here's the question. Would this work with a right triangle, but not with squares? What if we put hexagons, or semicircles, or any other shape?
Triangles.
Specific triangles on the edges.
Right triangle.
And the cool thing is, and what Pythagoras didn't figure out, hey, give me 30 seconds. What Pythagoras didn't figure out, at least there's not evidence of it, is that this will work given any shape you want to. So imagine with me, visually imagine, we put a semicircle on each end here. So when we think about the semicircle, this would be the diameter, right? And how do we find the area of the circle? Do we use the diameter? We use the radius, right? So we would have pi times radius squared, and we would do half of that. Now, if you want to take a moment to really embrace the difficult math, you can do this and calculate it. But I'm not asking you to do that because that's like college level math. I mean, not really, but we did it in one of my college classes. And I just wanted to give a little shout out homage to Dr. Smith, who I've kept the gift that he gave us from 2011 this whole time. Yeah, I know. Some of you didn't even exist back then. Saying that I was better than Pythagoras. Because what we did in that class was we solved this with any other shape we wanted. And then we did a formal proof of, yeah, this will work. Even with circles, it works with any shape. Now, as long as right triangle, but it works with any shape that you can put on those legs.
Could I please have Corinne? Let's get us to the Perry office. Corinne to the
All right,
Perry
I'll
office.
unpause you.
Mr. Hudson, what was the date on that mug?
2011,
Yeah, but date.
spring. I mean, it was spring quarter.
So what date?
I don't, like April. Like
what
April.
date
I'm done with this conversation. There wasn't a date. It says axiomatics because the name of the class was axiomatics by inquiry. Now remember, the reason we do Desmoses are to play with the math and just experiment and see what we can do. The last 5 minutes of class, you are welcome to hop over into Khan Academy and work on one of those 2 triangle assignments. Now, if we go to the first assignment that needs your attention about the possible third length of a triangle, when it's not a right triangle, it's a bit trickier. And if you don't remember those rules, I've got 2 videos posted here. One from a new math channel, well, not new math channel, but new to me, that I discovered that goes a little bit like more in depth and like it's actually got a person and they're talking about these examples. Great video. This one is more like animated, right? And I'm not playing the audio and I'm not letting them play too long because I am still recording. But it does a great job of looking at what sides can work and what sides can't work. So if you want a refresher on that, you are welcome to check out those videos. But also, we'll talk about one of those in a second. Like, I just want to give you guys a moment to head start. Yes.
Which triangle ones are homework? Because there's 4.
Go by due dates. Right? So going by due dates, these are in order. So these two. Okay. So, I mean, really the one is high priority. The other one is a little lower priority. Because we're going to keep doing like Desmos during class, but also a little bit of time to work on homework. So you might see this exact problem on your homework. You will probably see one similar. If you are choosing to ignore me right now, that is your choice. That, like, I don't care. You can ignore me if you want to. So if you have a triangle that is not a right triangle, and you imagine trying to connect it with a third side, certain lengths will or will not work. For example, if I grab some of my little sticks over here, that like the video that I posted, and we try to make a triangle with, I don't know, this one, and this one, and this one. Can I make a triangle with these?
No.
Why not?
It doesn't work.
But what if I try real hard? I'm like, I believe. No? So what needs to be true about these two shorter sides compared to the longer side? So if this is 10, so wait, if that's 10, so wait, you guys said it needs to equal. So that's 10, I got 6 and 4, okay.
They need to be greater than.
Yeah, that's not a triangle.
They need to be greater than the.
No, it's not a triangle.
They need to be greater than the.
So you're saying it needs to be greater, so swap out my 4 for like a 5? So now if I stand these up, now I get a triangle. So if you forget your triangle inequality theorem, guess where you could look to find it? In your math notes. It is back on the final section of pages, right? But here's your reminder for triangle inequality theorem and the Pythagorean theorem. It's all right here in front of you. And our famous triangle, 3, 4, 5. So, what would be the lowest, like the minimum length that we could use here? But we actually can't use it, but it's like our boundary point on the bottom. If we lay this down, if we imagine rotating this down, what is it?
16.8.
Ooh, you went the other way. So Joe just gave us this. 16.8 would be if we rotated out. Right, and we're saying, well, how far out would this be and still make a triangle? So 16.8 we cannot use. It's too long, but we could use 16.7. What about the lower boundary point? What's the shortest side? Now, we couldn't use it, but what's, anyone? 0.8, and we cannot use that because it would lay down flat, but could we use 0.9? Yeah, because 0.9 and 9.8 will end up bigger than the 8.8. Or, I think I said that wrong. But either way. All right, have a great day, guys. Were you here yesterday?
No.
That's why, because we tried to fix all that yesterday.